Ben & Jerry's runs 2 factories in Vermont, and between them they turn out close to 1,000,000 pints a day. Both of them run around the clock. The milk comes in from a co-op a mile and a half down the road, and the cream alone goes through at 6,700 gallons every 24 hours. And up to half of what ends up in your tub is air. Nobody's breaking a rule doing that. The air is designed in, and without it, you'd be chipping ice cream out of the tub with a spoon. So how much of what you paid for is ice cream? Why did some of the most trusted names in America quietly lose the right to print the words ice cream on the carton? And why does a tub that's been sitting in your freezer since March taste faintly of sand? 3 questions, 1 machine. It comes late in the line, long after the mixing and the waiting, and everything interesting about ice cream happens inside it in about 15 seconds. The first thing that happens in an ice cream factory is that somebody makes a liquid called mix. Cream, skim milk, sugar, a few eggs, and a fraction of a percent of stabilizers, blended together in a tank while everything is still warm. Nothing is frozen yet. Nothing is even cold. At the Ben & Jerry's plant in St. Albans, the milk comes in from 250 partner farms and sits in silos holding 6,000 gallons apiece. And every flavor they make, all 75 of them, shipped to 38 countries, starts from one of only 2 mixes, sweet cream or chocolate. Committing to a new flavor costs more than people think. The minimum run at that plant is 80,000 pints. As one of their flavor developers puts it, the team liking a new flavor is the easy part. 80,000 strangers have to like it too. There are rules about what can go in it. In the United States, a product that wants to call itself ice cream has to carry at least 10% milk fat and at least 10% non-fat milk solids, and it has to hold at least 1 6/10 pounds of total solids per gallon. Those numbers come straight out of the Code of Federal Regulations, and a product that misses them has to be called something else. The fat is doing more work than people assume. It carries the flavor compounds, and it coats your tongue on the way past, which is why a low-fat tub can have identical sugar and still taste thin. Now, for most of the history of this stuff, none of it could be made at scale. Ice cream was a batch product. You froze a churn, you emptied it, you froze another one. Then in 1926, a man in Louisville, Kentucky named Clarence Focht, built the first continuous freezer that actually worked. You poured mix into one end and collected ice cream from the other, without ever stopping. That's the whole reason ice cream stopped being a shop product and became a factory product. Focht's machine is still, in outline, the machine they use today. The blending tanks are bigger than they look. At one Australian plant, the blender holds 6 tons and moves about 14,000 liters an hour, and the skim milk powder goes in from 25-kilo sacks, lifted by vacuum rather than by arm. Before the mix can be frozen, it gets heated, twice. The first pass is pasteurizing. The mix runs between hot steel plates and comes up to somewhere around 175 to 185 degrees Fahrenheit, and it stays there for 25 or 30 seconds. Older plants do it slower and cooler, 150 degrees, held for half an hour. Either way, it kills anything harmful and it melts the fat, which matters for what comes next. Because next it goes into the homogenizer, and the homogenizer is the loudest, most violent thing in the building. Still warm, somewhere in the range of 65 to 75 degrees Celsius, the mix gets forced under enormous pressure through an opening barely wide enough to see. The fat globules hit that gap and shatter. They come out the far side between 2 and 10 microns across, small enough to stay suspended in the liquid permanently. Skip that step and the fat separates and floats, the way it does in a bottle of unhomogenized milk. Do it properly and the emulsion never breaks. One plant engineer calls the homogenizer the beating heart of the factory, and he's not being poetic about it. Every texture decision downstream depends on getting the fat small enough here. Then the mix gets chilled hard, down to just above freezing, and it goes into a tank to sit. The mix ages. At St. Albans, they hold it 4 to 8 hours, and in other plants it can run overnight. Nothing visible happens the entire time. Underneath, the fat is crystallizing, the proteins are pulling in water, and the stabilizers are swelling. The plant's own explanation is that the ingredients need time to get to know each other, which is a friendlier way of saying that a mix which hasn't aged won't whip properly and won't hold its shape. An ice cream factory spends more hours waiting than freezing. From the first blend to a hardened, packed pint is 12 to 24 hours, and the majority of that is tanks doing nothing in the dark. Meanwhile, the flavor goes in. 20 vats, one base, and whatever that day's run happens to be. The aged mix goes into a chilled barrel, and about 15 seconds later, it comes out the other end as ice cream, plus 4 degrees Celsius going in, around -5 to -8 coming out. Here's what's happening in that barrel. The mix freezes against the cold wall, and a rotating blade called a dasher scrapes it straight back off again. At the same moment, air is being pumped in under pressure, deliberately as part of the design. Freezing and whipping are the same operation. That's the trick. And it's the thing most explanations of ice cream get wrong. There's no separate churning step. It happens once in one machine in 15 seconds. The industry has a word for the air. They call it overrun, and it measures how much extra volume the air adds. Put a gallon of mix in and take 2 gallons of ice cream out, and that's 100% overrun. A tub that's half ingredients and half nothing. There's a ceiling on it, and it's set by weight. Federal rules say finished ice cream has to weigh at least 4.5 pounds per gallon. Whip in too much air, and the tub comes up light, and once it's light, it fails. Which brings up something you may have read. Around 2013, several Breyers products stopped saying ice cream and started saying frozen dairy dessert. Butter pecan, cookies and cream, Rocky Road. The version that went round the internet was that this happened because the products were 50% air. Snopes went and checked. The actual trigger was butterfat. The milk fat in those recipes had dropped below the 10% line, and that's what moved them out of the category. That category is worth a moment of your time. Ice cream has a federal standard with numbers attached to it. Frozen dairy dessert has no federal definition at all, which is precisely what makes it useful. A product that misses the milk fat line can still sit in the same aisle, under the same brand name, in packaging that looks the same as it always did. Those 2 words in the corner of the carton are the only thing separating them. The same dial explains the price ladder in the freezer aisle. Industry figures put gelato around 20 to 30% overrun. Premium and super premium pints sit somewhere between 25 and 50. Cheap tubs run toward the legal ceiling, which is why if you pick up 2 pints of the same size and one feels noticeably heavier, the heavy one has less air in it. You can do that in the shop without buying either. What leaves the barrel sits somewhere between a milkshake and soft serve. About 22 degrees Fahrenheit, still soft enough to pump through a pipe. That softness is the whole reason the next step works. Every chunk and ribbon goes in after the freezing through a separate feeder further down the line. Send cookie dough through the dasher and you get cookie dough paste. Send it in downstream and the pieces survive whole. Ben & Jerry's run some of the largest chunks in the business, and there's a specific reason for it. Ben Cohen has a poor sense of smell, which means he tastes very little. So when he and Jerry Greenfield started the company in a converted Burlington gas station in 1978, he pushed the thing he could perceive: texture. Decades later, the brownie pieces are still oversized because one of the founders couldn't taste the ice cream around them. From there, the line splits by format. Tubs get filled at speed. The automatic filler at St. Albans drops and packs 270 pints a minute. Bars get pushed through an extrusion head, which is why every bar of a given brand has the identical silhouette. And the coated bars get dipped, which is a better trick than it looks. One Australian plant melts 10 tons of chocolate a day for this. The bar arrives carrying so much stored cold that when it hits the warm chocolate, it freezes the coating onto itself almost instantly. The shell sets on contact. The ice cream underneath never gets long enough near warm chocolate to soften. Then quality control, where the abstract rules turn into people with knives. 6 pints an hour come off the line and get cut open. Inspectors check the layers are even and go looking for air pockets. A small gap is fine and has its own name, a functional void. A large one fails the batch. Every pint gets weighed, and anything under the cutoff doesn't pass. That 4.5 pounds per gallon isn't paperwork on a shelf in Washington. It's a scale and a reject bin. Last comes hardening, and speed is the entire point. At St. Albans, the pints ride a corkscrew conveyor called a spiral hardener through a freezer running at -10 Fahrenheit, where the wind chill can reach -60. 3 hours later, they're solid. Other plants use straight tunnels and take considerably longer. From there, the pallets go into cold storage at around -25 Celsius, where they wait for a truck. Rushing it isn't optional. Harden ice cream slowly, and you grow big ice crystals, and big crystals feel like grit. The target is a very large number of very small ones, averaging around 40 microns. Below roughly 50, your tongue reads the texture as smooth instead of icy. Then it leaves, and everything that happens next is working against it. Plant to distribution center, center to truck, truck to store freezer to your car to your kitchen. Every one of those handovers is a chance for the tub to warm up slightly, and the industry has a name for the damage: heat shock. It works like this. A small warming melts the smallest ice crystals first. When the tub cools again, that water refreezes onto whichever crystal survived, and the survivors are the big ones. The small crystals never come back. Repeat that a few dozen times over 2 months and the ice consolidates. Fewer crystals, each one larger. Nothing has spoiled and nothing has been added. The ice has simply reorganized itself into pieces your tongue can feel. And this is what those stabilizers from the beginning have been for the whole time. Well under 1% of the recipe, usually under 0.2%, and their job is to restrict how freely water can move through frozen ice cream, which slows the crystals from finding each other. The least interesting line on the ingredient list is the one defending the texture all the way to your spoon. Ben & Jerry's ship their pints 8 to a case. 8 pints is exactly 1 gallon, and they'll sell you the case, but they won't sell you a gallon tub. The stated reason is that a container that big sits in a home freezer for months, and they'd rather it didn't. A company sizing its packaging around heat shock tells you more about the problem than any explanation of it. One more thing while you're in there. The door is the warmest part of a freezer and the part that gets cycled every time somebody opens it. It's the worst place in the appliance for ice cream, and it's where most people keep it. So the air goes in at the exact instant the ice cream freezes, out of the same machine, inside the same 15 seconds. Without it, you'd bring home a solid block you couldn't get a spoon into, which leaves a question I'd like settled. Cheap and light or dense and heavy? There's a case for both and everybody's certain they're right. Comments, and if you went with dense, you're probably the sort of person who piles things on top, which raises the matter of the gummy bears. They come out of a factory stranger than this one. The molds are impressions pressed into trays of starch powder, thousands at a time, and the sweets sit in that powder curing for the better part of 2 days before anyone touches them. It's the oldest trick in confectionery, and it's still how almost all of them are made. That video's on your screen now.